So now we're going to talk about variables. Variables in computer science are a way to store a value. Now what and how we store that value is not too important. We can have a value that is a word that could be stored as a string, or we could have something that is a character like the letter A, and that would be stored as a char. We could have a number like 1 or 12 that will be stored as an integer or an int. Then we have different things like a float, which can store things like 1.01 or 111.13. These values are what is called mutable, meaning that if we stored the number 1 in an integer at the top of a program, later on we could change that number to be 3 or 7. Now a local variable is what you'll typically encounter when executing a function. So let's say you're within your main function and you want to create a variable called num, and we'll store an integer in it. So we could say something like int num equals 3. Now there you go, you have a local variable. Now this variable can be changed later on in the main function by saying something like num equals 6 or num equals 7, but your variable is stuck within the scope of that function. And the scope typically starts with the curly brace at the beginning of main and ends with the curly brace that closes out the main function. And this local variable is now stuck within this scope, so it can no longer be accessed in another function outside of the main function. And once the main function finishes its execution and returns, this local variable called num is gone. So in contrast to local variables, we have something called global variables. Now a global variable is declared at the top of the program and can be accessed anywhere in the program. So let's say you declared a global variable at the top of your program called test. Now this variable could be accessed anywhere in the program. You could access it in your main function or a function below that. But if you ever try to create a local variable in one of these functions with the same name as test, there's a conflict because you don't know which variable you want to use. Do you want to use the global test declared at the top of the program? Or do you want to use the local variable test that you're trying to create within this function? Now this is one of the reasons why we don't want to just use global variables freely. There's something called cluttering the namespace. Even if you don't mean to, you may accidentally create a local variable later on in the program with the same name as a global variable. And this doesn't pose a huge problem when you're working in small 10, 20, 30 line programs. But once you get up to thousands of lines of code, you won't remember exactly what you have stored for global variables. So one thing to consider when using local and global variables is to think about their scope. Now scope refers to where these variables can be used in the program. So a global variable has what's called global scope, meaning that it can be used anywhere in the program. Once you initialize that variable, it can be used in any function, whether it be the main function or a function 10 functions down called foo10. It doesn't matter where you use it. But a local variable has specific scope, and the scope of that local variable is determined by where it is initialized. Now the scope is typically determined by the opening brace of the function that the variable is declared in until the closing brace of that function. So let's say you're in the main function, you create a variable. But now within this main function we call another function foo. In the function foo, we can't call the variable we just created in the main function because it's not in scope. That variable is only in scope within the main function. So we could use it further on within the main function, but not within a function that is called from the main function. So like the stack and the heap, the global variables are stored in a certain part of memory. Now this part of memory depends on the system that you're using. The global variables have two separate spots that they're stored. One for initialized global variables, such as if you had declared int test equals 5 at the top of your program. And the other area is for uninitialized global variables. If you just said int test at the top of your program and was going to set the test variable later on in the program. So now we're going to talk about something called hash define, which is a way to give a symbolic name to a constant. And here we have an example of a C program that calculates the area of a circle. And at the top of the program, we'll do something that says hash define pi 3.14159. Hash define doesn't technically create a global variable. Rather, it tells the compiler's preprocessor to find and replace all instances of pi with 3.14159 before compiling. Nevertheless, it becomes a useful technique for declaring constants for use throughout the program. Now looking at the area function, it takes in a float rad and simply returns the area of a circle with that radius, or pi r squared, or pi times rad times rad. And this is where the hash define plays a key role, because the compiler will basically replace that pi symbol with the number 3.14159, and so we don't have to write that over and over again, And later on, if we decided to use more digits of pi, let's say 3.1415926, we could just add that to the top of the program and wouldn't have to change it later on in the program. This is a good use of hash define. We don't want to store pi as a global variable because it could change later in the program, and we know pi doesn't change. It's a constant. So this wraps up our topic of global variables. So today we talked about the difference between local and global variables, when to use them depending on their scope, and why not to use global variables at will, because of cluttering of the namespace. I'm Joe McCormick, and this is CS50.